In this gravitational question, we have an imaginary planet, a 7.2 times 10 to the 25 kilogram planet with a radius of 8.40 times 10 to the 6 meters. Now, 1.2 times 10 to the 5 meters off of the surface is a space station. And from the space station, there's a little tiny spaceship, which is 3,800 kilograms, which is going to take off from the space station and try and get away from the planet. Now, we have a nice little spaceship right there, and the radius is changing. Now, since the radius is going to be changing, that's a huge indication to me that I probably want to be using energies in order to solve that problem. Okay, now, when this ship starts out at that location, it's got potential energy. So right here, that little spaceship has potential energy from the planet. And as the spaceship goes farther away, it is going to have its potential energy change. And that change of potential is going to be equal to the change in kinetic. So let's just start by finding out a couple things here. So we've got a little spaceship, 3,800 kilograms. It's 1.2 to the 5 meters away from the surface of the planet. And we are going to just say, magically, it is going to take off instantaneously at 2,500 meters per second. And let's see if we can find out how far it goes. So how far is the ship going to go before the gravity of the planet will actually stop it? So again, with the radius changing, huge hint that this is going to be involving energies. So when the ship starts out, it's got potential energy, right? It does have potential energy at that location because it is off the surface of the planet. It's radius with gravity. It's got potential energy. So let's start with that. If I find out its potential energy at its starting location using GMM over R, G is the gravitational constant. We've got the mass of the main planet. We've got the mass of the spaceship divided by the radius. Now, the radius would actually be the combination of the radius of the planet plus the distance off the planet from or to where the spaceship is at the space station. So it's actually a combination of the two radii put together. And if I do that, I can find out that my radius is going to be approximately 8.520 times 10 to the 6 meters. And I put that into my radius, use my mass as my G value, and I can calculate the potential energy to be 2.142 times 10 to the 12 joules of potential energy. Now, as the rocket takes off, it's magically going to have an instant speed of 2,500 meters per second just for an instant. I know it's impossible, but whatever. It's got kinetic energy. So we can calculate how much kinetic energy the ship starts with just by using 1/2 mv squared. And if I do that, I can find out that the ship is going to take off with approximately 1.2 times 10 to the 10 joules of kinetic energy. Now, as the ship moves up, its potential energy will actually decrease, and the change in potential is going to be equal to the change in kinetic. So when it gets up here, it'll have a new potential energy which will be smaller than the one it started with. And the difference between the potential has to be equal to the change in the kinetic energy. So to find out its new potential energy after it's stopped, what we can do is we can start with the potential energy it started with, and then subtract the kinetic energy that it started with as well. Because again, the change of potential has to be equal to the change in kinetic. And if I do that, I can find out that its new potential energy is going to be 2.130 times 10 to the 12 joules. Okay, so it started with 2.142 times 10 to the 12 joules of potential energy. It then used 1.2 times 10 to the 10 joules of kinetic energy to get farther away, reducing it by that amount, leaving it with 2.130 times 10 to the 12 joules of potential energy when it eventually stopped. Now that I know its potential energy when it stopped, I can find out its new radius. So if I take the same expression we had before, okay, so let's be the new potential energy is going to be equal to GMM over the new radius, and I can solve for that new radius just by rearranging the expression. And if I do that, my new radius is going to be approximately 8.572 times 10 to the 6 meters. So I've got a couple radii now. I have my initial radius, which was this one. That's what it started at, and then used kinetic energy to get farther away. So its new radius is that one right there. So to find out how far it went, all I have to do is subtract my two radii. So I'll take my radius here, and just find the difference between the two. And if I do that, I'll find out that the ship went approximately 47,000 meters higher up before gravity from the planet stopped it.